Yeah. I think we're going to do some of that today. Like, I don't know, I guess you haven't taken a look at the detailed agenda I put together over the weekend. As of 10:30, I'm going to put them into little groups, and they're going to go off and create their own databases. So yeah, we're going to do a lot of hands-on today. Okay. Okay, well, I'm already streaming. I'm just trying to line up the whiteboard, so we'll get it going here in a minute. Okay, bye.
Was that Harper you were talking to?
Yeah.
He texted me wanting to know the baby stream.
Yeah. He texted me too.
Did this?
Yeah, that's all we need.
Mm-hmm.
That's good.
There's still the JSON problem, but working on it.
I didn't have a chance to take a look at it. I was working on 3 client projects this weekend.
No, the JSON parsing, you know how it gives you a colon in Postman? But I get an equal to.
You got a what?
I get like an equal to sign instead of a colon, so it messes up the whole thing.
Huh.
Sir. You know what? I didn't even get out. I was trying to find
Well, usually I don't, but right now, at this moment, I do.
Yeah.
We have this stupid summer program going on. We have like 4 programs on campus, and I was going for breakfast, but they were all in line. Like the line was out of the door. I was like, yeah, I'm not getting food right now. So I'm stuck eating this.
I heard a woman, awesome filming kid. Right from the go. Yeah, I'm gonna see it. I heard about
It's whiskey. Perfect there. And there's
I don't think I've ever seen whiskey that color. It's too light.
It's too light, it needs to be darker. It's rye.
Only that's a malt.
Yeah.
Can you all hear me in Richmond?
Only single malt.
Single malt. Have you had
Hello, hello, hello.
Pappy Van Winkle? Had any of that? No.
I think. Yeah.
What's your favorite kind?
Village. Yeah, I only drink with my dad. I can't afford that shit alone. It's his fault.
Blame
He
him.
made me start on those. Like the first one I tried was that. So you can't expect me to go down to like some crappy thing after that.
Nope. You have high class now.
Yeah, stuck for life. Good thing I don't drink whiskey that often now.
Right. Good.
I think that's what he meant to do. Yeah, literally don't buy it on my own ever.
Has to be for something.
Yeah, unless my dad wants something.
Yeah. You drink with your dad.
Like when I'm back home, Bombay, then I do. This is the saddest breakfast ever, just one this for you.
I'm jealous of it. It looks delicious. There's chocolate in it.
Yeah, it tastes good.
I saw that. Yeah. Be careful what you say to me. Everybody in Richmond can hear everything you're saying.
Oh, man. I see it.
I just canceled it when I saw that. You trust consistent dynamics. I just trust X.
That's probably the same thing.
So that's bad.
That's terrible.
We're just having a hard day.
My morning's bad. Imagine how it's going to be by the end of the day.
Better, because it can only go up.
Nah.
No. Someone needs to fix the automatic starter.
What?
The SQL server not actually starting the service.
I had a fun day on Friday with my PG admin 4. That thing just would refuse to start. And then I had to install PG admin 3, and then that was a story in its own. I was at the point where I wanted to pick my laptop and throw it.
Like a frisbee?
Not like a frisbee, like a shot put. Yeah, shot put.
Slightly like a frisbee.
No. Yeah, but then when you get out, the shot put would destroy it.
A frisbee is like a wing.
Rather I'd get a shot put and throw it on this thing.
Well, right, there you go.
You get flick of the wrist with that thing closed, it's gonna fly.
Yeah, and I mean, this is light.
Yeah.
Yeah.
This here explodes, you cut through the air, aim for a palm.
Were there links to any of the streams? Links to any of the streams from last Wednesday and Thursday? I'm keeping a Word document. I've got Tuesday and then I got
I think if on YouTube you can do what's called subscribe to the channel. I'm not a YouTube user, but I think if you subscribe, there are a couple people that have, then you get a full list of everything that's public.
Oh, okay.
That'd be
Do you
easier.
know what channel name is?
I think it's called Sightsource and Power.
Okay, I'll look.
Yeah. Yeah, it should be findable. Yeah, I wouldn't keep a Word document in that stuff because it's liable to change.
Okay.
Okay, let's go ahead and get started. It's 8:30, 8:31. So we'll expect to be interrupted for the first couple minutes. Just trying something out. I've got a headset I'm walking around with. Harper, can
I feel
you
like I'm
still
on
hear
the
me?
plane.
Richmond, can you still hear me?
No one wants you. I might sit in my
Can you
seat.
still hear me? The reason I'm wearing a headset today is because this is my favorite part of all coding. And when I get excited, I don't sit down. So just for your benefit, I put this on just in case I start walking around. Can you hear us, Harper/Richmond? Maybe not.
Oh, we can hear you. He said we can hear you.
Audio is from laptop.
Well, you gotta change the audio settings.
Yeah,
On
I just did.
OBS.
Okay. Bless you.
Who's next?
I bet Richmond heard that.
Start in the morning now. Some aggressive sneezing.
Vigorous.
How about now? There we go. I see it going down here. Now, let me walk to the back of the room and continue to talk. Can you hear me now? Can you hear me now? And they're going to catch up in, I guess, about 30 seconds. There we go. Okay. Good morning. Okay, so as I was saying, this is probably my favorite topic in all of technology, so let's get to it. Why is it my favorite topic? It's because the database is the most important piece of any application, in my opinion, and a lot of other people's opinions too. You can build a great database and run an application for 5 years. The application will age out. Today, Node.js is really cool. 5 years from now, people are going to say, what? You're using Node.js on a new project? Just because that's technology. If it's 2 years old, it's old news. So that's just the world you live in now. So 5 years from now, it's like, oh, that's an old Node.js app. Nobody wants to look at that. Nobody knows Node.js anymore. They're off doing X, Y, Z. It's like, okay. Just so you're not going to be shamed in public and possibly stoned in developer conferences, what you're going to do is possibly rewrite the application. So you rewrite the application to something brand new. Well, are you going to rewrite your entire database? No, because you have all the data you ever wanted for 5 years of production systems, and there's nothing wrong with it. So what you do is you pick up your database, back and restore if you want, put it somewhere else. You might change the database format. Maybe it's no longer SQL Server that's cool. Maybe it's PostgreSQL or the next relational database that does it ever so slightly better, okay? And we're going to see how similar they are tomorrow. So you're going to back up and restore it, change a couple field data types, and I've got my database. So the power in database technology is that it doesn't change every 2 years. It is somewhat of something that you can hang your hat on. If you get this down, E.F. Codd, back in 1970, is the PhD mathematician that came up with relational theory. And we're not going to get into any of that stuff. But this stuff has been around since 1970, 7-0. And people have been using it in production systems since then. And there's no signs of it abating. So yeah, non-relational, NoSQL, that's the new cool thing. I personally think it's somewhat of a fad because, yeah, there are enormous systems out there that require NoSQL or non-relational. But they're like 2% of all systems built. So right now, it's probably 20 or 30% of the systems being built. Oh, I've got to go non-relational. Okay, that's way overkill. And you introduce yourself to Pandora's box of all kinds of other problems that nobody talks about. There are no joins in most of these non-relational databases. And you've seen from Friday how joins can be useful. If you have information over here and information over here, you want to put it together and come back as one piece of information, that's how you get it together. Guess how they do that in non-relational? They still need to do that same kind of thing sometimes. We'll talk about it a little bit on Wednesday. We're going to design our own non-relational database. But they write code. You have to query all your first one. Then you have to write another query to query all the second one. And Kathy's looking at me like, oh, that's no big deal because I used to do that all the time in natural database. And then you have to do an inner loop to actually put it together manually. And then you show the results. That's like this much code. And in SQL, it's a join. So, yeah, Lotus Notes and some of the others back in the late 90s were the ones like, oh, let's do this different. Who wants to use a relational database? Oh, that's old. Well, I think that was a bad turn of events, personally. And I think karma will catch up with them. So probably 10 years, 15 years down the road, there'll be a lot of non-relational to relational rewrites, if I'm right. But we'll see. Today, buckle up because we are going to cover everything in relational design and SQL that has been glossed over. I don't know if you realize, but see these little these titles? You can click on them and look at all the things I have in store for us. And that's just this morning. Okay? We're not going to cover all of them, don't worry. But we are going to cover the highlights. And I'm going to open it up so, you know, Allie, ask questions. Today is going to be more interactive. It's not going to be me preaching to you, okay? It's going to be more, we're having a group exercise here too. Right here, it's first thing, right after I explain a couple things, we're going to go and you're going to create your own database. The power in relational databases and this SQL stuff is not the syntax. The syntax is pretty much straightforward. You can get it. It's how do you put it together to solve real world problems? And we haven't even talked about that. That's what today's all about. So I told you over the weekend to have a couple, 3 things that you need to think about and get down. One is, what does ERD mean? Entity relationship diagram. So that's this pretty picture where you have boxes and they're, you can relate them with lines. That's entity relationship diagram, ERD. You learn a new technical word. Wow, somebody in an interview. So relationships that matter, one-to-many. Somebody give me an example of a simple one-to-many relationship. No code, no technology, no syntax. Just, we're talking English. Simple phone number. Is that what you said? Oh, a customer has 3 phone numbers. Okay. So what are the one and many relationships there? Okay. So we've got 2 tables. And I asked for a one-to-many, and Brianna spoke up and said, what about a customer who has multiple phone numbers? So the one would be customer, and the many would be phone numbers, because for each given customer, you could have 0, 1, or many phone numbers. So that's the thing I really need you to get down. When I first looked at this, maybe I'm a little bit dense, but it took me a while to get these basic things and how it worked in the context of relational databases. When we're talking about one and many, we're talking about rows, number of rows, okay? So 1 row in the customers table, possibly many rows of phone numbers in the phone numbers table. How do you connect those 2 tables? That a join in SQL, yeah, but how in the database structure? A foreign key. And Derek had this nice little mantra, children always point to their parents. And that took me like 3 months to get right, because when you start going and writing these databases and you know there's a one-to-many, and then you put the foreign key on the wrong table. It's like, okay, how do I remember that? It's the one that has lots of records. The child is the one that has the foreign key, because it's got to remember where its parent is. It's got to remember what it relates to. And you're going to have first-hand experience with making that mistake this morning. So give us about 30 minutes. You're going to go do it yourselves. So one-to-many, perfect example, Brianna. Great. Many-to-many. What's an example of a many-to-many? We're speaking English here, no syntax.
Lots of students having lots of hobbies.
Okay, students and hobbies. It sounds like Aaron has been hitting his head against the wall over the weekend trying to build a database. He mentioned something on Friday about creating a database like that. So let's use a slightly different example. How about a student and tests? Okay, so the classmarker.com has a database that I'm not privy to because it's a packaged product. But each one of you, let's call you a student, and there are multiple tests, multiple assessments, whatever you want to call them. There's a definition of that assessment. So there's like, this past one you took is 50 questions, and you have 40-some people in Richmond and Winston-Salem. So you have 2 tables there, test definitions and participants, or students, whatever you want to call it over here. Now, each student, say Melissa, is going to take more than 1 test. So you have to have another table to say test results, or how did Melissa do on that test? Now, why can't you just put it on one of these tables? Because Melissa's going to take more than 1 test. So she may have 10 tests she's going to take over here, and I think in reality like 3. But so you have results 1, results 2, results 3 in this many-to-many table. And it doesn't stop there. This is where I'm about to show you some real-world examples. We're going to do ad hoc design in just a second. But you need to get these 2 types of relationships down. So you've got student or test, and test results, which is the middle table, the many-to-many. But in test results, what else do we need to remember about that test result? We probably need to know, when did she start taking that test? We need to know the final result, like how did she do out of 100%? But what about all the test question answer details? This is actually a really interesting example in design. So on this test attempt, let's call it that, there were 50 questions. We need to know, did she answer number 3 correctly or not? Where do we put that information? Another table. What is that table related to? It's related to the test results table. Is that a one-to-many, many-to-many? What is that? Where's the one and one? Is a one to many? It's what's the one and what's the many between test results and test question results? Test results is the parent. Test question results is the many. Exactly right. So you'd have 50 rows in this case pointing to this test result for Melissa for test 1. When I'm making these points, that's like foreign key to test. So which test are you? Foreign key to user, that's Melissa. And over here, it's got a primary key, an ID on test results. And this down here, the test and I'm going to use the whiteboard. It's going to be so much easier than my little hands moving around. Test question results over here points to test results as the parent. So as a matter of fact, I promised it. Let's write that up real quick. Enrichment, tell us if you can't see this stuff. So we got student. This is actually how you start designing a database. You don't get into the fields. You kind of infer that, yeah, there's a primary key, there's a foreign key, but you do all that with just lines because it's faster. And you can go back and write the SQL DDL in just a second. We'll show you how to do that. Student, test. So this is like test definition. Test results. Let's call it result. There's going to be a question definition. And there's a test question result. So you thought, oh, I got the SQL stuff. Well, today you're going to feel, no, maybe not so much.
Barbara would like you to switch to full camera instead of it being the little tiny box.
Okay, hold on just a second. Let's figure out how to do that. I'm going to desktop, laptop, webcam. Oh, yeah. Let me just make it really small.
No, not big. Because they want to see.
They want to see that. Yeah, sorry, hadn't had enough caffeine. There you go. Is that better? Y'all tell me. Okay, so one to many. What are the symbols in a simple ERD? Little infinity sign or two little circles means many. One is one little circle. And actually, technically, I think there's colored circles and other things to mean 0, 1, or many. It's like, no. One circle or two circles is good. So what does that mean? That means for every one student, you could have 0, 1, or many test results. Maybe Melissa hasn't taken a test yet. Maybe she's taken 10. For every test, you may have 0, 1, or many test results. If I just define the test, nobody's taken it yet, you're not going to have any records. Question. That's the question definition. So does that relate to test result? This is where the fun in database design comes in. It doesn't relate to a test result. There's another table over here that we're not even talking about called test question. That is like the definition of the test. This is going to be a many, one, and what does this relationship define? Test question.
A test can have many questions, and a question can be on any test.
This allows us to have a question definition, and we reuse that question on multiple tests if we want. It has nothing to do with somebody taking a test. It says, this is question number 3 on this test, but there's a test number 10, and this happens to be the same exact question. It's question number 7 on that test. You're just reusing that. Okay, so that's what that does. And this is quickly going to become unwieldy because this is a full type of example. But let's get back to this. Test question results. So this says, Melissa took test 1, and on question number 3, she got it wrong. That's what that tells us in English. So how do we relate that to the rest of our database tables here? It does relate to the question. Is that a one to many or many to many? What is that?
That's a one to many.
One to many.
One question, many question results.
Good. So we got it connected there. It's also related to somebody's test results, right? So these two are related. How is that related?
Many to many.
It's not a many to, explain the many to many thought process.
I was thinking you're going to
more than one test?
Yeah, this is for a given test, though. So he was thinking, oh, you're going to have test question results all over the place. You're right, but this is going to relate to this through, and this is going to refine it just to one test results. So for one test results, test one in this case, in our example. By the way, if you're ever confused about what do these relationships mean, think about real-world data. That's what I always go back to. It's like, okay, you're building this to put data into it. If it doesn't make sense with the real-world data, you're doing it wrong. So validate as you're going through is like, what am I doing there? It's like, that's test one in my mind right now. Student, it's like Melissa in my mind. Question, Brian.
So I guess I'm a little confused as to why we don't create a relationship between the student and the test itself as to which test, the student and which test. We're running that through the test result, but where is the which test the student took that we're looking for results from? And I see that, but...
Let me repeat your question. So Brian's question is, why can't we connect student to test? Well, student is like Melissa, and test is like test one.
Right, but there's 3 or 4 tests.
Yeah, there could be 3 or 4. And what we're really trying to capture here is, how did Melissa do on test one?
So we don't care about which test she took.
We do. So the question is, how do we capture which test she took? Because there's going to be a test ID. This little thing means it's probably going to be a field called test ID, and this is going to be like student ID.
Okay. So within the test box up above.
That's going to be an ID.
That'll be an ID and that'll be the...
Let's call it an ID of 2, and this is going to be 2.
Key will be, okay, and that'll identify which test Melissa took. Got it. Okay, I'm good.
Yeah.
Thanks.
So let's say Melissa's 4. This foreign key value is going to be 4. Did you see that cross-reference table? And it's like, oh, I've got these ones in there that Derek was showing. Unfortunately, when you look at the direct raw truth in the database, in a relational database, that's common. What you have is primary key and foreign keys, and it doesn't make any human sense. The only way it makes sense is if you put the diagram together, and it's like, oh, what does a 2 mean? Well, let me trace it back. Its name of the column is test ID. There must be a 2 as a primary key in the test table. That's how you kind of link them together. And I showed you very briefly when we took a spreadsheet and we broke a column off and we put it over there. What did we have to do? We had to have a primary key so we could talk about that parent later on. And we had to have a foreign key so it could reference that parent. So that's overhead in a relational database. So that's why we're doing this, just so we can put it back together later on. So test result, that's going to say, what's in that table again? Walk me through this. This is very important because in the real world, you're given a database with like 50, 60 tables. It's like, go figure it out. Start writing queries on it by lunch. It's like, okay, you got to look at the norms of what do people normally do in relational database design. Find the primary keys and foreign keys. Look at any foreign keys, key references. That'll give you some clues. And then it's like, okay, let me do some diagnostic queries. Let me do select top 10 from this. Let me see what kind of data is in there. Because sometimes developers can be tricky about what they name their columns. So a column named something doesn't have any guarantee about what's in that column. You have to go look and see what's in there. And then usually it starts making sense. And it's like, okay, I see test result here. I see student ID and test ID. That's probably going to be foreign keys. What's also probably going to be here is columns, which when we're doing the high-level design like this, you don't write in your columns usually. You just like, this is the relationship of the tables. Then you can sit down and it's like, when I'm doing creation of the test result in SQL Server Management Studio, or as I'm going to show you in data definition language with the create table statement, you can just, okay, what columns do I need for a test result? And that's when you stop and it's like, okay, let me go a little bit slower and think about what do I need to capture here? And it's not the end of the world if you forget a column because it's one line of SQL to add a column, not a big deal. So just get the structure down, get the skeleton, and then you can put some meat on those bones. So, question.
When you turn your head,
They can't hear?
audio clips, yeah.
Sorry, yeah, let me clip it. Actually, there's something for that. There. Yeah, this is, no, it's over here. So I clipped it. Sorry. Is that any better, Richmond? Hopefully.
I also had a question though.
Question.
So, first let me get this right. The test question, are you going to have multiple of those or just one?
Multiple what?
The test question table?
Okay, so
Right?
we did have a question. Are we going to have multiple test question tables? If I did, I would have done it wrong. The idea of in a database design is you don't make tables to be duplicated or have to be duplicated. So there's only going to be one because that defines this test has these questions in it. That's what it does.
So then wouldn't it be more efficient to connect test questions with test question results rather than question?
So this is exactly what I want you all to do when you're in your little group and designing a database. I want you to debate the pros and cons of different approaches. So he's saying, why don't we combine test question with test result?
Test question results.
Test question result. Okay, when somebody, say Melissa goes and she clicks on the application screen and says, I'm taking test number 1, how does the application know which questions to show her then?
Isn't it connected to the test to know which test question it is?
No, that's actually what this table does. It says this test 1 has these 10 questions in it. If you don't have that, how are you going to know?
No, I'm not saying to remove that. What I'm saying is to connect test question with test question results instead of question with.
When you say connect it, you mean make it one table?
No, like the link thing, the one to many.
Oh, you want to have a relationship there instead of directly to test?
No, to question. So instead of question connecting to test question result, why not have it with test question and test question result? Too many questions with that.
Because you don't
So-
know what's the
Take out
question.
the question box.
I'm missing your questions. So,
So take out the question table
No, just don't
and
take it out.
have test question connect to text question results directly.
because the question actually has the definition of the question.
He's saying also,
It's just actually let's do this. Let's actually flesh this out, and maybe it'll make more sense about what my intent is here. And while I'm doing that, Mujit, maybe you can rephrase your question.
Okay, so we have a relationship between question and test question result, right? The bottom ones.
Right.
Test question results in question.
There's a relation, right?
That's a one-to-many, yeah.
Yeah, instead of that, why don't we have a relationship directly with test question result?
From test question.
You have to have two tables to have a relationship. Which two tables are you talking about?
Test question and test question result.
Okay.
No, because they're all connected.
No, I'm saying it, we already have the test, so then you're just taking a group of questions from that test,
Exactly.
and then saying the result of those group of questions,
No, I'm not telling you to remove it.
right?
So you're saying remove this line,
No. Yeah.
remove that line, and connect it directly here.
So
You don't have
instead
to.
of this.
It's the
this
same
one,
thing.
Yeah, just connect that to this.
The answer is you can, and that's a one-to-one or many. That exists.
Yeah.
That relationship you're pointing out. So Muda, I now finally understand what Muda is asking. He's saying, well, can't you draw a line from test question to test question result? And the answer is yes, because let's draw in some of the column names. This is going to be, what's this foreign key going to be called probably? This one. Question ID. So let's call it QID. And what's the primary key up here in test question? Well, test question ID. Okay. And this is a one-to-many. So this is the many. That's the primary key. What's the foreign key? To here. Question ID. So you could join question ID to question ID, no problem. It exists. We don't draw it like that because that's a side relationship. Just because this has a foreign key that happens to be the same as that foreign key doesn't mean that's how it's related. It just so happens that, let's put that in English because that always helps me understand if this is right or not. Melissa took test 1, and on test 1, there was a question number 3. Okay, so question number 3 is going to live here, but we have like a record that says question number 3 was on test number 1. So there's going to be 2 foreign keys. So there's going to also be a test ID here. So it's going to be like one of those 111 tables. The question definition is going to be like 3 and then the text of the question. So this is like the definition of the question. So that when it comes up on the screen, the application has the record to show Melissa so that she can answer it. Test question result, there are no records in here until after she responds. As soon as she responds, there's going to be like question ID, and then we could say, oh, on test 1, question 3, you could join directly to there if you want. But you have to really logically go through question to see if it makes any sense, because question ID belongs in the question definition table. Question?
Isn't this kind of how you made random questions, like each time they took the test, as opposed to it would be the same questions each time they took the test?
So I believe what you're inquiring about is, could you randomize the question presentation order?
Because if you had it directly related, it would be a lot more difficult to have randomized questions.
You're confusing what the application can do with the data and how the application data is stored. So just because we have a list of 20 questions listed in that test question table, we could have a sequence, SEQ, if we want, or we could just leave it entirely up to the application. And let's say, you know JavaScript now. So say the JavaScript query is back and it gets your list of 10 questions. It's up to the JavaScript and the application code how it wants to present in which order. That's up to you.
It's like a question bank where it takes random questions out of the question bank for the test.
Okay, so that Aaron, we have an Aaron translator here. So Kelly is saying that what Aaron really wants is taking the questions out of the question bank. So this is like the question bank, and then making a random order for a given test.
Not a random order, random questions, like more questions in the bank than you're giving to the student, and it chooses like 10 out of the 20. So each time you take the test, it would be different questions.
Okay, so you don't. So the instructor wouldn't know which questions are going to be on the test beforehand?
No, you would. Out of the bank of 20, yeah.
Okay, so say the instructor defines 20 possible questions that may be on the test, but every student may only get 10, and the 10 they get would be randomly selected.
Yes.
That's a slightly different design, okay? You'd have to have a different table relationship there, because then you don't know until they click go about which ones you're going to actually put into their list. But it's very similar. We could talk about that, brainstorm that later. But yeah, it's very, very similar to this. So Richmond, I probably need to change this again, don't I? Okay. Oh. Okay. You know, you probably don't care to see me right now. Let's put me down there. Okay, so let's go ahead and create this. Just I want you all to understand a real world ad hoc example. And time is flying. Let me... By the way, I wanted to let you all know I had a conversation in the hallway this morning. And one of the things that came to mind is I probably need to prep you all for what it's like to work in the real world as an application developer. And one of those things has to do with the interaction between different technology groups. So, and I'm actually going to call on you, Kathy. So while I'm doing that, y'all can listen to the story while I'm writing this DDL. So let's call this. So in the real world, I told you about the holy war, the difference between different types of application developers. You have front-end application developers, database application developers, and middle-tier application developers. The ones that say that, as David put it, they use the big boy languages. So you're about to learn a big boy language later on this week with C#, but I would argue that JavaScript is already a fully fledged language that you can build whatever application you want. We're going to learn Node.js and see how to use that with MongoDB on Wednesday. So one of the things I wanted to tell you about is, should you be successful, and I hope you do, and we're going to help you to try to find an entry-level job as an application developer, you get placed into, say, a large corporation. To protect the guilty, I'm not going to name anybody, but they pretty much all work like this. You are tagged from the day you walk in the door as you are a front-end application developer, or you are a Ruby application developer. You're a Python application developer. You are a database administrator. You are a database developer. As soon as they put a label on your forehead and they say, go off and be with your own kind, you get into a little group. And how do you get applications done? Sightsource, we build the entirety of the whole thing. So we talk with the customer, we gather specs, we build the whole thing, and we deliver it. We put it in the cloud for them if they want. In the real world, outside of a small company like ours, this is what you should expect. You go to work as a front-end application developer. You conceive of, I need this service. You got to think about your users and your providers. So as a front-end application developer, what do you need to do your job? You need web APIs. You need something that gives you the data so you can make it pretty on the screen. If you're a middleware, a middle-tier application developer, who are your users and who are your providers? Your users are the front-end application developers. Your providers are the database administrators and database developers. If you're the database administrator or database developer, you don't really have any providers, which is why they kind of have an attitude. But your users are the application developers. The application developer is the ones writing the middle tier. So in the real world, Kathy, as an application developer, and this is experience I've had in several companies, not just where we shared common law marriage. You're an application developer, you know you need to add a column to a table. Just one column, one column. Say we want to capture Melissa's email address as part of her user record. So how do we get that done in the real world? What's the process?
Well, it depends on where you are, but in the many places I've been, you might have to fill out a database, DBA, database administrator request to have a field added and specify which database, which table, the field length, the data type, and they would put it in their workflow and eventually get to it.
Exactly right. So not only, now adding a column, let me remind you how easy that is.
Yeah.
Test. I'm not going to create the whole table, whole database, but I wanted you to see what I'm doing with these boxes and how they relate to real syntax. And I'm going to get back to exactly what, Richmond, did you all hear what Kathy said, or should I repeat it? And somebody, if you could tell me in the questions Slack channel, yes or no.
Repeat.
Repeat? Okay. Okay, so the answer was, in a typical corporation, and you answered that very truthfully, and that's exactly, I didn't want to just tell them that because they probably won't believe me anymore, but you are an objective observer here. So the answer is, and this is on a good day, they have a digital system, not paper anymore, and you would have to have a login to that digital system. You would sign in as a developer. You would go to a special screen and hopefully select the right category, subcategory. You find the correct recipient. In some systems, it's better than others about routing. And then you type in, please add a column to this table in this database. And you say submit. And it goes off into the ether. And several days later, a database administrator is like, I don't know what you're talking about. Canceled. Okay. Resubmit, call him on the phone, take him out to lunch, take him out for a coffee. It's like, this is all I want. Here's the script. Here, just run this script, please. It's like a couple days later, they'll get back to you. It's like, okay, job done. So now you've got like 7 days past. And oh, by the way, you need to go back into the ticket system and you need to close that ticket. Otherwise, they don't get the kudos and the pat on the back for actually doing developer requests. So their metrics look bad. Okay. So all of this nonsense around adding a column to a table. Okay? That's the real world, unfortunately. And that's why software costs so much. It's not because what we do is so difficult. It's because they have layers of management because we're expensive. We wouldn't be so expensive if you just uncuff us and let us do what we know how to do. Now, that system works. That system is not going to go away. So I'm warning you, if you go to work for a large company, they will teach you a whole bunch of things. Say you get placed in the DBA group. They're going to teach you some things that this is how you work in a large company. Here's how you make it lights out, solid. Here's how you deal with users. They're going to teach you a lot of good stuff. But it comes with a poison pill. It was a poison pill for me. I couldn't handle that kind of atmosphere. I'm more the anti-bureaucrat, so anything bureaucratic, it just chafes me. So if that's fine for you, you're going to go slower. You're going to have a lot more time to learn things. So that 7 days, what do they expect you to do? Your daily status report, if you have one, it's like, I'm waiting on the database administrator, so you can do that all you want, Theoretically, you should go off and come up with your next data. So question from Jamila, you just sit there for several days? Like, probably not just sit there, but you might go on and try to do what you can with your application in the absence of that really critical field that you needed. You might come up with your next DBA request and start the 7-day process, start it rolling. So it's really, it's probably not always that bad. If you're lucky, it may take a day. But still, it's a day where you're sitting there, it's like, I need to go to the next step, and I can't. So, unfortunately, that's the reality of things. I'm not lying. And, ask Harper, Richmond. So, test question, test ID. So, I'm not going to build this whole thing, but I want to build enough so you understand what these boxes mean. So, question ID. And this is actually how I'm going to build the entire database like this, and you see, it's like, it's complaining. It's complaining because there's no such table as question yet. Well, that just means I've got to create the table above this one. So question ID, sequence.
I think it's complaining because we have 2 test question tables.
That could do it too.
Yeah.
So test question, test question, and then I should probably name, let's call it question. Question. Test question. Okay. Now, see how it's blue? That means it's a keyword. I'm not going to use keywords because I'm just making my life more difficult. Okay. So I've got a test, I've got a question, and I've got a test question. If I have a comma there. And let's do test result maybe.
Did you want your description to be looks like it's a question word?
Why does your question
So do I want to change the word description? I often do, but I didn't want to teach you bad habits. Harper's like, no.
So do you not need a foreign key in the question table?
Foreign key in where?
Question table.
Well, let's think about it. Look how it's drawn. So it's the one in one-to-many 2 different ways. What would be the foreign key?
You wouldn't need one because it's the double parent.
Okay. All it is, the question table as it's intended is this is the definition of a question. Now you probably want to know when was it created, who created it. So created at. By the way, there are 3 or 4 different data types for date times. If you care only about the date, what's the data type? Date. If you care about the date and time, that's where it gets a little interesting. How granular do you want to keep your date times? Do you care down to the second, the millisecond? Then you need a date time. If you care about down to the minute, use a small date time. Okay? They have these cutesy names for a reason. Small date time means instead of 8 bytes, it's half that. So they do some black magic internally. It's like, I'm going to save it in a much smaller space, half the space. Half the space for a database field makes a big difference. Why does that matter? Because, and this is part of, I'm actually covering a lot of what I'm intending here today, believe it or not. Fundamentals review. Skinny is fast. Skinny is fast. Remember that in databases. What do I mean by that? An integer is 4. When I'm saying these, I'm saying bytes on disk. Why am I talking about this crazy nonsense like bytes on disk? We were just talking about English a minute ago. Bytes on disk matters when it comes to performance, because the more bytes on disk there are, the bigger things are to compare in the database engine has to run around and work so much harder if you've got a varchar 50 as a primary key. So varchar 50 could be up to 50 characters wide. And you have that as a primary key. That's really, really bad. Versus an int. How wide is an int field? 4. So we're talking 4 times, 50 divided by 4, that many times worse in performance. This is why if you have a varchar, you could even have a varchar 80 or a varchar 100 as a primary key. Primary key is not so bad. Foreign keys where it kills you. So let's imagine that we decided this test ID is not going to be an integer. We got the bright ideas like Ali taught us all the bad stuff. We're going to do our own way, and we're going to learn why things can be so much better than the way Ali taught us. We're going to make that a varchar 50. Now all of a sudden, you have how many foreign keys already? You've got one here. You've got one there. You've got foreign keys to that all over the place. What's the data type of every one of those foreign key columns? Varchar 50. Varchar 50 again. So it's like a poison that's crept into your entire database. Every time you have to join, joins are not magic. I can tell you about the internals of what the optimizer is doing, but you probably don't care. I can tell you about why does it matter about the sizes of your key columns. Because if you have 4 characters here, and you're asking the computer to match 4 characters over here, which is what you're doing to join, it's pretty easy. If you have 50 characters over here and 50 over here, it's going to be that much longer for it to figure out, pull it from disk, compare it, and give you the right results. It's just more complex. That's the difference between a fast system, ones that return like that, and some that may take 3 or 4 seconds. They both return, one's good and one's bad. It all is decided on the database. So it all comes back here. Okay, so question, let's get through the first 3 or 4 tables, and then I'm going to let you go and actually do this yourself. Test, question, test question, test result. So help me build out test result. I just copied and pasted, and that was inappropriate. That is identical. We also have a relationship to students. We don't have a student table, so we're going to have to do this. And so now we have a student table. See, it's like that. You don't have to play with the SQL Server Management Studio Designer. I just created a table. Well, it's not real yet because I haven't pressed F5. But that's all it is. There's no magic. And by the way, it's kind of hypocritical to use the designer because even Derek said, oh, here's a stored procedure. Here's a temporary table. What was the syntax for a temporary table? Identical to this. You might as well just learn it. So test result, student ID and test ID. We probably also want to remember when they took the test. Taken, started at. Now, this is where, do we care about the date and the time? Do we care about down to the second? I probably don't care about down to the second, so I'm going to say small date time. And let's say, we're not going to do that now. Okay, so what have I got here? Should I make that bigger? Okay, so I've got a test. This is all it really looks like. So we got test. Oftentimes what I'll do is I'll move the tables that don't have any foreign key relationships up to the top because those are your parents. So I'm going to move that up here. Test, student, question, and if you look at this, let's compare this to the diagram. Question, test, student. Those are 3 tables that don't have any many-to-one relationships. Those are all the one in the one-to-manys. So start with those. So you put them up the top. Now we've defined them. We can reference them. We can say, oh, that's my parent later on. So test, student, question. Test question, now we're talking about, this is not going to be a readable set of data. That's going to be 1s and 2s and 3s. You're not going to be able to read that without a join to put it all back together. Test result. Conceptually in English, somebody explain what the test result table represents.
The number of questions the student got right or wrong.
It's going to be, yeah, the final result, their score, kind of. And we haven't even got the score, but it's a place for it. I was about to actually add the score column, but is that relational or non-relational? It would be non-relational. It would be denormalizing because I can theoretically figure out the score because I've got a test question result table. And I could do a select against that and say, give me the number that they got right versus wrong. So if it exists somewhere else in your database and you could figure it out with a select statement, usually you don't want to create a column for it. And if you do, you created a computed persistence column that we'll talk about as an advanced feature later on. So the reason we didn't add score there is because we could do a select and figure it out. That data exists somewhere else. Don't store it more than one time if you can avoid it. So let's get back to, everyone understand what I'm doing here? Yeah, and notice I haven't even talked about the content here. The answer was I'm creating the tables and the content. If you want to add 10 more columns to your test question table, feel free. Just understand conceptually what that represents. Putting your columns in the right place is very important. Let's get back to the overview. And so, entity relationship diagram. One-to-many relationship. In a one-to-many relationship, where does the foreign key go? In the child table, the many. Many-to-many. How many tables do you need to model a many-to-many relationship? 3, not just 2. That one takes a little while to grasp, so don't worry about it if it's not like the back of your hand yet. That's why we're going to do some practice. I'm going to wait on that. That's joins. So why are we even doing relational? Just back up, like why does relational database stuff exist?
More efficient.
The answer, one answer is it's more efficient. It's a way to eliminate duplication or minimize duplication in your data. Let's take this for an example. I've stored the definition of that question one time, but I can reuse it in multiple different ways, and I can present it in multiple different tests based on joins. So in inner join, I can show that question text again, but in the database, I've stored it one time. That's less data, which means small is fast. So less data means you can get it from disk quicker, and you can reassemble it with SQL selects fairly easily with joins. If you need to update it, here's where it pays off in dividends. Let's say I didn't store that in one place. Let's say I stored the question definition on that table or on this table. What happens when I had a typo in the question? I need to go write an update statement to update who knows how many records in multiple tables. If you have it properly normalized, is relational design. Normalized mean it's stored usually in one place. I can update one record in one table, and magically, it looks to the user that I fixed it everywhere. But really, what's happening? It's all joining back to the same column. So I fix that one record, and that joins, the joins in the application, make it show up fixed everywhere. That's the power that you get for free if you design things relationally well. So why not one big table? Because there's duplication, because it's verbose. If I had a long spreadsheet of things, and I say which venue we're going to be at, say this class, Empower, which venue we're going to be at in Winston-Salem, I would have to copy and paste Forsyth Tech down for every day except for like Fridays. That's a waste. The proper way to do that, and this is, you're going to start smelling this. You're going to start like, oh, that feels wrong. I'm not going to duplicate that. I'm going to create another table. Yeah, you start getting an instinct about it after you do it a few times. So you'd create a venues table, and you'd have a foreign key to the venues table. Why do you do that? So you can store it one time. That's, if you're getting things deduplicated and storing in once rather than multiple times, you're on the right track. Question?
So for people that are maybe a little more front-end developer minded, I guess, it would be like if you had a 10-page website Instead of fixing something on one page, you would change it in your CSS to affect everything rather than changing the color on 6 different pages. You could just adjust it in your CSS and it would blanket everything.
Excellent example, but very, very technical. So let me try to repeat that in English. So David's speaking up, it's like, I really like the front end concepts. Is this kind of like when instead of having a style attribute on 10 different HTML elements, and I say background color black, you could make one class definition in a style tag at the top of the page and say dot class name, background color black in one place. And if you want to change it, you change it in one place. It's exactly relevant. I don't know how many people understand that really technical metaphor, but yeah, that's right. Okay, so usually when we have metaphors, you try to make it easier, not more difficult. Impromptu group model, we don't really have time. Actually, let's do one more, just because I love this stuff. We're going to do one more. This time, no preconceived notions, nothing up my sleeves. You all choose a business case, something in the real world. It's like, let's create a database for that, a theoretical database. And we're just going to do it like this. Let me put Richmond back in. I'll give you a minute to think about it.
Let's do schools, the school system. It's a university department. So you have the school and then different departments. History department, computer science department, art department.
Okay, so one suggestion was let's talk about academia and school departments. And I'm so anti-bureaucratic. Let's not do that. It's going to be it's like departmental fiefdoms. No, thank you. Anybody else?
So, I've been talking to my husband over the weekend. He actually wanted me to throw this out there to see if we could find a better way to. So he works at a mattress company. Whenever they have to make orders, they have to fill out this huge Excel spreadsheet and like find all the different pieces that go with it.
Ouch.
Yeah, so he wanted to know if there was a way that he could do a database for it instead. So it would be like you're creating a mattress, so you need the springs, everything that go inside the springs, and
all the components of the mattress.
all the components of the mattress instead of having to like list out everything.
Okay, so the suggestion there, this is actually a real world example. Anna's husband apparently works in a mattress store, and in the mattress store they use an Excel spreadsheet to list out which components go into creating the mattress. Is that right? Okay. So in a real business, you have multiple databases in play. You have one for order entry, one probably for manufacturing, which is what this sounds like. And when users call their Excel spreadsheet, their beloved Excel spreadsheets databases, I stifle a laugh every time. It's like, okay. I smile and nod. It's like, okay, let's make this better for you. So an Excel spreadsheet is what they're using now to generate mattresses. Please don't share the name of the company because I probably never buy a mattress from them again. But let's create mattresses. Let's brainstorm. What do we need for? Let's assume some things about his job role. Let's assume he's going to be responsible for getting the mattresses built. So, and he's got a bunch of raw materials sitting over there. Does he have to place the orders for those raw materials? Yes, that's a whole inventory management and receiving system too. We can go as deep into this as you want, but this is probably a database that has 100 plus tables in it. So let's start with just the core, and then you can see where we'd branch off and go down the rabbit holes. So the core of what he's doing is he's got production lines probably, like 4 or 5 lines at least, and each line has a list of workers on it. And each line has work instructions. It's like, at this step, you're going to have a kit that you're going to put together, and you're going to do it like this. You might have a quality assurance person right there that checks in on you once in a while, and then it goes to the next step, just assembly line type stuff. And at the end of the line, you've got a brand new mattress ready to go. So for a database, you need to know what raw materials have I got. So let's create a materials table. Actually, instead of me doing this, let's do it more interactive, okay? You all heard the same problem I did like 10 seconds ago. So let's build it together. Let's make the mistakes, and I'll tell you, you probably don't do this because of this, and so on. So let's start with raw materials. Raw materials, that's just going to be like the springs and like the covering. I don't even know the technical terms, like padding, all that stuff, yeah. Now, in order to identify those things, you probably need to know what type of materials they are. So you probably have to have materials type table. And that's one to many, many to many. What do we got going on here?
Raw material can have one material type. A material type can have many materials.
Yep. One material type to possibly many raw materials. So if you have 10 different types of springs, you'd have one record in here that says spring. You'd have 10 different actual materials. And you'd probably have, instead of raw materials, it's probably called component or something like that goes into it. So I'm gonna rename that component, because really this is what goes into your end product. Okay? You probably also need to know, say somebody ships you some bad springs from China, you need to know who to call to get it fixed. How do you know that? Everything's got to be in your database somewhere. So how do you know where this component came from? Manufacturer. Where would that go? It's another table. And I'm not going to write out manufacturer. Once again, bad habit, MFG. So one to many, where? Possibly many components, yeah. So Springs R Us has 3 different types of springs you buy.
But theoretically, couldn't the manufacturer to component be many to many as well? Like, couldn't multiple manufacturers do multiple components, like 3 different spring producers or 2 different foam producers?
Very good point. David says, could this be a many to many? And it depends on how you infer what we're putting in these tables. So he's saying, if you have spring ABC, couldn't that spring be provided by 3 different manufacturers and you have like bidding on which one? The answer is often yes, but in order to differentiate, they're not going to sell you usually the exact same model number. It's going to be, it's the same logical thing, but we're going to call it something else. So they're going to have a different product code on it.
Well, at the end of the day, you're going to buy one specific component from one specific manufacturer, even if that manufacturer produces multiple. So what we're talking about here has to do with what you own at this point in order to make the mattress.
Yes, Brian's point is that, they may offer several, but at this point, when it gets into your component table, these are the things right over there next to the production line that you can put into a mattress. So you probably have more than one spring, don't you? How do we keep track of that? You probably have to have an inventory table before it gets into component or after it gets into component. So the inventory table would have like a lot. Like when you brought it in on the receiving dock, there is a pallet of springs. So you probably need to know the receiving mark, bill of lading information, things that, these 100 springs came in on this lot. Because if that spring shipment was bad, you need to be able to trace it back to exactly that and pull the other 90 that you haven't used yet and send it back to them in case there was a defect. Yeah. So that batch ID, we're not going to get into that, but that's another rabbit hole. You'd have to create like 5 or 10 tables to keep track of that properly. So we're not going to get into that. We're going to keep this fairly simple. So that would be receiving. Okay, so I'm going to put like a circle. Receiving is over here. Purchasing and receiving.
You probably need an order table so you know what components go into an order.
So Scott's saying you probably need to have an order table so we know which components go into an order. Anna, does he care about fulfilling the order specifically, or is it just, I'm going to make 100 mattresses today and it's somebody else's problem to ship it out?
Well, he gets the order so it's not.
So it's built on demand. So he knows he's got to make 5 for, okay. So that orders are very relevant. It depends. See, that's where you have to come back and ask questions to the customer. It's like, well, what kind of business are you? A lot of companies will build 100 and they put them in a box over there and they wait for somebody to order them. They're building to order. So we do have to know exactly where is the demand for this. So we need to have another table. What are we going to call it?
Order ID.
Let's have an order table. Is that enough? No.
I think we have to go back over to during the manufacturing process. Every single mattress is going to have an ID as being built.
Oh, we're not even there. We got tables here. So Brian wants to go back over here. It's like we're not finished building the mattress yet. We can't sell it. You're right. But we're going to have a couple more tables here. Let's do the order and we'll join it. We're going to come back. So we got an order. Is that good enough? That's probably called order header. So order just for simplicity, but you were about to say customer. We need to know who placed the order. So we probably have a customer table over here. You know, these days of websites, you probably have husband, wife, children, multiple logons to the website. So the customer is like a logical account, but you could have multiple sign-ins for that one customer. How do we do that? What's that? That's usually the right answer, and it is here too. Can we have another table? Yes, you can. So we're going to have customer contact. How is that related to the rest of the stuff? Notice we haven't related these things. It's fine to draw it up there. Just come back and relate them all. So customer contact, customer order, how is all that stuff related? Walk me through this, because that's really what you need to get down.
So you're going to have a one-to-many from customer to order, because one customer can order.
Okay, that's right. And you got your turn, then I want Sasha to go.
That's exactly what I was going to say.
Well, I guess you have to do another one. So let me repeat that for Richmond's sake. So one customer can have 0, 1, or many orders. So that's what that means. And how do we relate contacts?
Because one customer can have many contacts.
One customer can have many contacts. So it's a one-to-many. Most things are one-to-many. You just got to figure out which direction. So we got a customer. Now, in order, are we going to limit, when a customer calls up and do they say you can only buy one mattress because that's all our database can handle? No. You can have as many as you want. So how do we say that? You have an order line. So an order line is, it's actually, if you see in an invoice, and you all have, you have the order header. It's like, this is your customer information. There's your account. And then you have little line items, and they actually call the table usually order line. And each one of those relates to what did you buy on that line item. And at the bottom, you have a total. So order line. How is that related to anything else?
That's what's actually going to put together the mattresses on each order line.
That's going to be a finished mattress on each order line because they don't sell the components. They don't sell the springs. They sell the whole mattress. And then we're going to get back to what Brian was saying. You haven't built the mattress yet. Yeah, I know. We're going to get there. So order and order line, how do those two relate? One to many. There you go. Does it make sense to have an order without any lines? No. No, because then they wouldn't have bought anything. So what's the point? So that's one of those cases in technical database stuff that we're never going to talk about because it's useless, in my opinion. You could have a 1 to 0 or many, because 1 to 0 or many would not be relevant here. So you have to have 1 to 1 or many. There is a different variant here that says 1 to 0, 1 or many. Doesn't matter. It's still a 1 to many. It's just a special case. So in this case, you're always going to have at least one line to go with it. Order line. So what does an order line have on it? So imagine you're looking at the invoice. You just bought 3 mattresses. What do you see there?
Sorry.
you'll have your, basically you'll have your list of your three mattresses that you ordered, the subtotal and the total, and then possibly order numbers for each of them.
Okay, so that was Brianna, and let me repeat what you said. She said you probably have a list of 3 items, and on each item you're going to have a number over here. What's the number, by the way? The price. We haven't even talked about that. And then at the bottom you're going to have a subtotal, and then you probably have some tax and some other things, and then you have a grand total. And you might even have a number next to each one of the line items. Like, this is my mattress ID. This is the serial number or whatever. Okay? So we haven't even got mattresses. So what goes here? We need to somehow create a mattress to sell it. So a mattress is composed of one or more components, right? So let's call it finished product. Or just product for short. We'll leave it like that. So finished product, it's made up of components, right? So what's the relationship here? Many to many. That was tricky. So now you have to explain it.
Well, you have multiple components for multiple types of finished products, right?
Yes. You could have 3 different mattresses or 10 different mattresses that all use the same spring. Okay? So that's the one-to-many that way. Now, components could also be in multiple different mattresses. A mattress is composed of multiple components, too. So a given mattress, you're not going to have just springs in it. You're going to have the covering, padding, and all that other stuff. So it's many in both ways. So you have to have a table in between. What do you normally call this, Kathy? Between finished products and component.
I would call it a lookup table.
Yep. It's in the many-to-many, but in this case, it happens to be probably the bill of materials.
Oh, okay.
Yep. So this actually happens coincidentally to touch on a very common database design case. When you're building things in a manufacturing plant, they have components, they have finished products, and how do you know what goes into that finished product? Engineers actually usually put this together, and they say, well, at the top level, this is going to be our assembly, our finished assembly, like our mattress in this case. Well, the next level down, you might have 2 sub-assemblies, which is like, say, the outer covering and the inner springs plus the padding. So you have 2 sub-assemblies. Then you go down one more level. The inner is made up of spring and cushion. So it's a hierarchy. And I'm not going to get into hierarchies and relating things, but I'm showing you this is the right way to do it. We're going to gloss over that and say this is a simple many-to-many. There is a slightly more complex thing going on here because it is a hierarchy. But so let's draw this as a many-to-many. How do we do that, Kirsty?
2 circles.
2 circles going both directions. As Derek put it, it's a child to 2 different directions.
What's the middle one called? I can't.
BOM, it's a bill of material. It says these components go into this finished product. And I'm using that technical term because that is the right thing in the real world.
Are we going to have like single, double, queen, and king inside finished product, or is that?
You can tell Brian has been on the marketing side of businesses before. He's like, how do I sell this to somebody? Okay, yes, let's talk about the marketing. So finished product, right now, we could either have just luxury sleeper or whatever you want to call it, just the name. You'd put that as a column in here. But if you want to have, let's talk about marketing. So the marketing department probably wants to say, have we run a promotion on that specific mattress recently? So you might have a promotions table. And the promotions would be, so you maybe have a sale. You send out a Sunday coupon thing. What's the relationship here?
Finished product can have many promotions.
Yeah.
And a promotion can go for many products.
The same promotion? Okay, there's a nuance. So Scott's saying, if you put out a Saturday or a Sunday morning advertisement, that's not going to have a promotion just covering one finished product. You're going to have like 3 or 4 of your best sellers there, right? So this is wrong the way I've written it. The right way is what? It's a many-to-many. It's a many-to, and does everybody in Richmond also get that? We need to understand the way I wrote it means that your luxury sleeper has an ad that you staple to a telephone pole somewhere, okay? Which is probably a very horrible way to try to market mattresses. But you've advertised just one product, which is very rare. It's probably not common to do that. Instead, Scott's saying, I put out an advertisement. I'm going to cover several things. As soon as this one promotion relates to multiple finished products, and one finished product can have multiple promotions, you have to have a many-to-many table relationship. So product promotion. And what are the relationships there?
Product promotion is the junction table and will be the child.
So many related to one on each of these.
So every time you have a many-to-many relationship, you have to break out another table to separate. Okay.
Sasha, just repeating it. Just to verify, whenever you have a many-to-many relationship identified, you must have a cross-reference table. Absolutely. That is a clear yes. And that's why I like database stuff. There's a yes and a no. As a matter of fact, writing queries, which we're going to do later on today, you can get to the right answer multiple different ways. Is one better than the others? Yes. Which one? The one that's faster. So, and you can measure down to the millisecond how fast is it? And you can compare the two. I'll show you how to do that later on if you're interested. We're not going to have a chance for me to share all the cool stuff that I know about databases that get you excited about it, but I'm trying to give you enough so that actually I'm going to show you anything you want. I've written down some really advanced concepts at the 10:30 session, which are probably good. Not so fast so far. So there are a lot of things that I'm going to say, which ones of these do you all find interest in that we'll cover? And if not, we'll cover it later on too. So we can go down this rabbit hole. There's probably another 20, 30, 40 tables to build here. And don't feel like that's discouraging. And it's like, I'm going to have to go back and tell him that, no, we can't help him. It's like, no, the answer is this is not a very complicated database. And just because you probably don't even need some of these tables for their use case. So just because we're imagining a large plant and we're imagining covering every possible scenario, you don't have to do that. If you built half of this, it's probably still better to capture information in that half of this database than it is in their spreadsheet. So take incremental steps. Just to finish off, in his use case, something to think about would be he probably has production lines and production line workers. So if you have Tommy over there that's fallen asleep on the job and the mattresses are coming out half done with half the springs in them, you probably need to know who is who's the culprit with data. How do you know that? You have to probably keep track of who's working on which line on which day and which production line this finished product came from. So you probably have another, this is production process. So these circles mean there's probably another 10, 15 tables down that rabbit hole. There's probably another 5 or 6 tables into marketing. Over here, order processing. Yes, there's going to be more here. What are some of the things we haven't even talked about in order processing?
Sales tax? Things like that.
Tax, yeah. So you just happen to come up with a really complicated example, Anna. Most databases are not this broad. Most of the time you have I'm solving one problem, and I'm going to build a database for that, and I'm going to build an application to do that. This could also be termed an enterprise resource planning system, which you heard of SAP, JD Edwards, those. They sell for hundreds of millions of dollars because they have databases that do this for you already. So you've touched on, that is the nerve of modern business. So probably something that I didn't want to scare people with, but it's good to understand the relationships. There's no magic. Just because they charge $300 million for it doesn't mean it's worth it. Most of the time, what are they doing? They're entering help desk tickets. They're waiting for each other to do work. Okay. So the order line, we didn't have one relationship. Order line's kind of off here by itself. We didn't actually succeed in getting a mattress to an individual. So there's another one. Complaints. We need a complaints table over here. Order line, finished product. Finished product is probably going to be, logically, what's the relationship there? Probably 1-to-1. So you could write it as just 1-to-1 like this. But, you know, I like to always choose a parent and a child, just so if you have to make a decision. So between these two, I would choose finished product, even though it doesn't, you know, you're never going to have one line item with more than one mattress on it. It's never going to happen. You can't even do that. So it's really just 1-to-1. But you can think of it as a one-to-many.
So that doesn't change if, say, a customer, they're ordering 20 mattresses and 3 of them are a specific king size and serial number, you know, product ID number. There's going to be 3 of those and 4 of the other, 4 of the next, and that doesn't change what you just said there.
So Brian's saying, what happens if they ordered multiples? Like, say that they have an enormous family or they're a hotel, and they've got, say, 20 rooms, and they want 10 of this, and for their luxury suites, they want to have 10 of these other types. That happens. That is probably dealt with one column, probably called quantity, and it's probably called quantity on which table? Yeah, I want 3 of them. So it's not another table, it's just another column. Question? So the question is, when you start talking about parents and children, I'm getting all confused. It's a synonym for parent is a synonym for one, and child is a synonym for many. So the reason we call it that is because, let's talk about order and order line. I could have chosen any of the one-to-many relationships on the board here. In order, say you have order 101. It's got children. It's a cutesy way of thinking about it of, you know, I've got this order, and it's got little children that are details about what this order is. In this case, I ordered 3 different mattresses, and I've got the luxury sleeper, the never wake up tired again, and, you know, different models, and I've got one line item, one record in here for that parent order. So the one, the parent, means it owns the children. It's those children belong to that parent. So the one is parent, the many is the children.
The child will also have the foreign key. So that's how I think of it, is the order is where your main primary key is. And since order line is a child table of order, that means it'll have order ID on there in that table as a foreign key. And so I think of all the child tables as being the ones that have the foreign keys that connect to the parent. And that's how they connect, is through the foreign key.
So what Scott was saying is that he also remembers it as, think about where you're going to put the foreign key. Think about what points to what. And he was explaining how, in this case, you've got order, which is parent, order lines. Which order do these order lines relate to? Which one is my order? It's got to have a foreign key on this table to relate to that table. So you know the foreign key is always on the child table. That's one of the nice things about SQL. There is an always. You know, that you get it down, it's going to take a little bit to get it down, but once you do, it's not going to change on you. JavaScript's going to change on you. So, questions about what we did here? You kind of understand the concepts as a first pass? Now, I want you to go use them. I want you to make the mistakes. Let's break up into groups of 4. So, you 4 here, and then next 4. And let's break up into groups of 4. don't stay in the room. Please walk around, go into the little area over here. Here's the assignment, and this goes for you too, Richmond. I want you to conceive of a real world, I wonder how we would create a database for X. And I want you to design, don't give me the columns, don't build it down to I need to have this primary key named that. I want you to create a diagram on paper that draws the boxes. This box relates to this box as a one-to-many or many-to-many and so on. Make the mistakes, debate it, tell each other you're wrong. Because if you're nice to each other at this point, you're actually hating that person because you're robbing them of the knowledge that they need to have. Help them out. If you hear something wrong, it's like, no, I think we should do it like this. Debate it, okay? Deal with a real world thing. It could be anything you want. Take a break now and then take about half an hour to do it. And I'm going to walk around and we'll walk through it and I'll contribute to the discussion. And then we'll come back and we'll talk about SQL. So the groups are, I'm going to start here, 1, 2, 3, 4, okay? 1, 2, 3, 4, and so on. You can create your own groups if you want, just have like 4 people in each.
All right.